Welcome to the Rapid Highcharts video course. My name is Tom Hombergs and I'm a software engineer based in Germany. In this course, I hope to get across some of the fun you can have with Highcharts while enhancing your web application with beautifully rendered charts that can either be static or interactive, whatever your requirements dictate. To follow the examples given in this course, you will need some very basic HTML and JavaScript skills, but nothing too advanced. In the first video of this course, we're going to have a first look at Highcharts and its companion frameworks Highstock and Highmaps, and get an impression of the resources we have available in the web. Also, we will introduce the development environment to be used in the following videos. Let's start off with the official Highcharts website. On the front page, you get a first impression about the three main products of Highsoft, which is the company behind Highcharts. Highcharts itself is a JavaScript framework that provides a wide variety of charts, ranging from basic ones like line charts, bar charts, or pie charts, to more complex ones like a heat map chart. It also allows you to configure the charts very easily without a lot of programming. Highstock is a spin-off of Highcharts that is specialized on creating charts that show the value of stocks or any other time-related data. Highmaps is the newest spin-off of Highcharts. Highmaps allows you to configure a chart that shows a map of the world, a single country, or a district within a country, backed with statistics that you can configure yourself. Note that the use of Highcharts is free for non-commercial projects only. If you want to use it for a commercial web application, you have to get a license. Let's explore the website a little more. A very handy tool for developing charts is the demo page for each of the three frameworks. This page shows what charts you can create and the code needed to create those charts. So this is a very good starting point for creating your own charts. Let's have a look at the documentation section. There is a general documentation page explaining most of the chart concepts. Most of those will be explained in the upcoming videos, so we'll not dive in any deeper here. Then there is an API documentation for each of the three frameworks. Here you can look up the exact features you can use to design your charts. Finally, let's have a more detailed look at the compatibility page. Depending on your audience, especially browser compatibility may be an issue. As you can see though, most browsers are supported by Highcharts. The older ones may take a little longer to render the charts though. Also, Highcharts depends on a JavaScript framework to do the HTML manipulation work. You can use either of the frameworks listed here, so you can choose the one you know best or that fits best into your project. Enough documentation for now. Feel free to browse the pages as you go, but many of the things covered here will also be explained in the next videos. Let's roll up our sleeves and have a look at the development resources we will use in this video course. First off, we will rely heavily on JS Fiddle when creating charts. JS Fiddle is a very handy online tool where you can edit JavaScript in one window, click the Run button, and view the result in another window. You can even save code snippets on JS Fiddle and share them with anyone you wish without creating an account. When designing a chart, this is the tool of choice. Next, you will have to download the code of the example dashboard application, either from the page at Pact, where you got this video course, or on my GitHub repository, which is available at this URL. Finally, you will need a code editor to code JavaScript in HTML files. Having a Java background, I usually use the IntelliJ IDEA, but any other editor you like will do the job. It would help a lot if that editor had syntax highlighting for JavaScript though. Let's sum up what we learned so far. We got to know the three main products we're going to show in this video course, Highcharts, Highstock, and Highmaps, and learned what their respective specialty is. We browsed the online documentation a little to get a feel for the quality and quantity of the information available to us, and finally we got acquainted with JS Fiddle and the GitHub repository used in this course. That's pretty much all you need to know to start building charts, so that's exactly what we will do in the next video. The goal of the second video in this section is to create our first chart with Highcharts. In order to do that, we're first going to have a look at the key concepts and terminology of charts in general and of Highcharts in particular. Once we've learned the vocabulary, we will then have a look at the code structure of a chart to be able to create our own first chart. The chart we'll create in this video is a pie chart that displays the hits on our imaginary website done with different browsers. This is what our chart will look like in the end. Nothing fancy yet, but we'll get there. Okay, let's get started with exploring some of the keywords that we'll use in the rest of the course. Highcharts has a pretty good set of online examples, so we'll start with the first chart on their demo page. We will explore the key elements of a chart on this line chart before mapping them onto a pie chart later on. The most important elements of a chart are the axis and the series. Usually a chart has a horizontal and a vertical axis, each measuring its own unit. This chart's vertical axis measures centigrade numerically, and the horizontal axis measures time in months. Be aware, though, that charts are not restricted to just two axes with Highcharts. The series in a chart contain the actual data that is displayed. This chart currently shows 4 series, each representing the temperature over the year in a different city. Besides the axis and series, there are some accessory elements a chart can have. In Highcharts, you can configure a title and a subtitle, usually displayed above the chart, and a tooltip to be displayed when you hover the mouse over the chart. You can also configure an interactive legend like this one, which allows hiding and showing of different series. Highcharts has many more features and options than the ones we have just seen, but we'll take a break here to get started on the coding. If you want to dig deeper into Highcharts concepts, have a look at the online documentation at highcharts.com/docs. So let's have a look at the code of a chart. On each demo page, you can click the very handy View Options button here to see the code of the chart that is currently displayed. If you're familiar with jQuery, you will notice the dollar notation in the first 2 lines. In the first line, we tell jQuery simply to execute the code in the following lines once the page was loaded. In the second line, we tell Highcharts to replace the contents of the HTML element with the ID container with the chart that is configured in the next lines. The chart configuration itself is a JSON structure. JSON stands for JavaScript Object Notation, which is just a fancy term for a set of nested key value pairs in JavaScript. Within this structure, we have access to the whole Highcharts API to create a chart that meets our requirements. Now let's go and create a pie chart. We start off with an empty chart on JS Fiddle. Feel free to open this URL in your browser and code along. Easy things first. Let's change the title to something more meaningful, like page hits, and hit the Run button and view the result. The title has changed. Next, we need some data to display. The data is contained in the series of a chart, so we add a series element to our chart configuration. Since a chart can have more than one series, Highcharts expects an array here. We add an array with a single empty series for now and hit Run again to view the result. Make sure to enter a comma between each of the configurations, otherwise you'll get an error. The chart is still empty, but you can see a y-axis and a series legend. Let's add some data now. The data is structured as an array of points, each having a label and a value. If we hit Run now, we see that Highcharts renders a line chart, which is not exactly what we wanted. So we still have to tell Highcharts to draw this chart as a pie chart instead. This we can do by simply adding the type pie to our series configuration. If we hit Run, it looks much better. But if we hover over the pie segments, we still see the ugly default label Series 1, which is rather ugly. We can change this by giving the series another name, like page hits. If we hit Run now and hover over the pie segments, we see the new label page hits instead. So that's our first chart. We'll create more in the upcoming videos. For now, let's wrap up what we learned in this video. We identified the main elements of a chart and saw that all elements can be configured in a rather simple JSON structure. We used the very helpful Highcharts demo page as a starting point, which is a good idea every time when you think about creating a new chart. Before creating new charts, though, in the next video, we'll create a dashboard application that will serve as a home for all our charts. All charts we build in this video course will be integrated into a little example dashboard application to get a feel of how to work with Highcharts in a real web application. In this video, we're going to have a look at the code of this example application and integrate the chart we created earlier into one of the dashboards. The dashboard application looks something like this. We have a sidebar navigation here, where you can choose the dashboard to be displayed, and a main content area here, where we will put our charts, each into its own little widget window. The widgets are empty for now and will be filled one by one as we create our charts. Let's dive into the code of the My Web Statistics dashboard. As mentioned in the first video of this course, you can get the code either from GitHub or from the Pact website. If you browse the source files, you see that it is organized in a common folder containing all JavaScript, CSS, and media files we need globally, and one folder for each video of this course, named by section and the number of the video within this section. Since this is the third video of the first section, we'll look into folder section-1-3 and open the file index.html with our code editor. This file pretty much contains everything needed to build charts with Highcharts, since the JavaScript files for Highcharts and jQuery are already included. It also provides the page frame consisting of the sidebar navigation, the widget mechanism, and all other elements you see in the browser window here. I used a pre-constructed HTML5, CSS, and JavaScript theme called admin LTE to create this page frame. If you want to know more about this theme, have a look at the URL displayed at the end of this video. We have 3 empty widgets on this page. In the previous video, we created a pie chart that displays the page hits distribution by browser, which would fit neatly into the widget with the title Page Hits by Browsers. Let's search the code for the word browsers to find the place where the chart should be added. The widget title is contained in an h3 element, followed by a div element that contains the button to hide and show the widget. The next div element is the body of the widget. If we add a little text here, save and hit refresh, we see that the text is displayed at the right spot, so we know that we are at the right spot. Highcharts needs an ID on a div element if we wanted to display a chart. So we add the ID browser chart to this div, so Highcharts later knows where to put the chart. Next, we open up the file charts.js that lies next to the index.html file. It contains an empty anonymous function that is executed when the page loads. Within this function, we simply paste the code from our previous JS Fiddle session that you can grab at this URL. Note that we do not need the first and last line because those are already included in the JavaScript file. Also, we still need to tell Highcharts where to draw the chart. We do this by providing the ID we added earlier to the JavaScript call here. Let's check that the charts.js file is really included in our HTML file. Right here it is. If we refresh our browser now, we see that the pie chart is rendered within the widget. So the steps to integrate a chart into our dashboards are first finding the widget in which to put the chart, then giving it an ID, and finally pasting the Highcharts code into the charts.js file. In this video, we also had a look at the page frame of our dashboard, which already contained the JavaScript we needed, highcharts.js and jquery.js. If you're interested in the CSS theme of the dashboard, have a look at the website of this URL. So that was the last video of the first section. In the next section, we're going to fill up our dashboard with more charts. See you there. Welcome to section 2 of the Rapid Highcharts video course. This section will be all about different chart types and their features, so we'll create a couple of charts to add to our dashboard. In this first video of section 2, we're going to create a line chart to display page hits on our website over the last 30 days, and have a look at Highcharts' support of date access on the way. In the end, we will integrate the chart into our dashboard. This is what our web statistics dashboard currently looks like. Right now, we want to fill out the widget labeled page hits over time here with a new line chart. Let's start with the chart. We will make use of the Highcharts demo page once again here to get a kickstart. The first chart on the demo page happens to be a line chart, so we simply click on the Edit in JSFiddle button to get a template to work with. The line chart we want to create should contain exactly one line displaying the page hits on our website for each of the last 30 days. Let's go through the code and change it to meet our requirements. First off, we don't need a title or a subtitle, since the title is included in the widget frame of our dashboard. Here's the first catch. If you don't provide a title configuration at all, Highcharts will generate a default title. Thus, we will have to provide an explicitly empty title with an empty text like this. And same for the subtitle. And the titles are gone. Next, the x-axis. It should contain the last 30 days. Let's say today is the 4th of November, so it should show today and 29 days before that, like this. We see now that the x-axis only goes to October 17th instead of November 4th. That is because we don't have enough data points in the chart yet. We can fix that by editing the series configuration. I'll remove 3 of the 4 series here, since we only need 1, and replace the data of the remaining series with 30 data points for the last 30 days. We also changed the name of the series to something more fitting like page hits. If we hit run again, we see that the chart now looks a little closer to what we imagined. Let's go through some of the remaining settings though to fix some more things. In the y-axis configuration, we remove the title, or rather replace it with an empty string, and remove the plot lines configuration for now. Also, we remove the tooltip configuration for now and disable the legend by setting the enabled parameter to false. Now the chart looks a lot closer to what we imagined, but it seems pretty awkward to enter the last 30 days manually like this. Luckily, Highcharts supports working with dates. We can tell Highcharts that the x-axis is a date axis by simply removing the categories and configuring the type to the value datetime like this. We see that the x-axis is now labeled differently. Highcharts now by default starts the first data point on January 1st, 1970 and sets the interval between each data point to 1 millisecond. To change the starting date of the first data point, we go to the series configuration and set the point start attribute to 29 days ago, so that the 30 data points we have are interpreted to belong to the past 29 days plus today. And to change the interval between each data point, we set the point interval attribute to the number of milliseconds in a day. We have an automatic date axis that Highcharts takes care of. As an additional exercise, you may want to change the format of the date labels down here to include the year. Start by looking up the configuration called datetime label formats in the Highcharts API documentation and go from there. Back to our chart. If you resize the chart like this, Highcharts even takes care of adding or removing labels depending on how much space it has. Let's take this code and integrate it into our dashboard. Simply paste it into the charts.js file and change the ID to match the ID of the HTML element it should be put in. And the result should look like this. Let's sum up what we learned. We built a chart but never configured that it should be a line chart, so note that this is the Highcharts default. We first configured the x-axis of the chart manually using the categories configuration, but learned that date axes are much easier to handle when configuring the axis as a datetime axis and let Highcharts do the work for us. In the next video, we're going to have a look at Highcharts' theming feature to create a common theme for all our charts. In many cases, like in our dashboard, we want to create more than one chart on a single page, and we want those charts to have the same look and feel. Luckily, Highcharts provides a theming mechanism for exactly this use case. In this video, we're first going to have a look at what we can do with a theme, then create a theme, and include this theme into our dashboard. If we have a look at the configuration of the two charts we have created so far, we see that they share a common configuration. Both charts configure an empty chart title because the title is already included in our widget windows. Using a theme, we can configure common configurations like this one at a central place instead of repeating the same configuration in each chart. Of course, we can configure visual things like colors and fonts as well. Let's have a look at the Highcharts demo page. Here you can select one of a set of predefined themes and click on the View Visual Theme button to have a look at the code that belongs to that theme. As you can see, this theme configures colors, fonts, the chart title, and even the axis of a chart. As a rule of thumb, you can configure everything in a theme that you can configure in a chart itself, because it's the same API. You apply a theme to all charts on the page by calling the function highcharts.setOptions like this. Let's create our own theme and start off with the title configuration. In our JavaScript file, we simply create an object called theme and add the empty title configuration to it like this. Then we call highcharts.setOptions to apply the theme to our charts. Next, we can remove the title configuration from our charts, since they will now take the title configuration from the theme. If we look at our dashboard in the browser now, we see that nothing has really changed, which is what we have expected. Just to show that the theme really works, though, let's add another configuration to it. If we look at the bottom right corner of our charts, we see that there is a link to highcharts.com. Let's remove this link using the theme. To do this, we add the credits configuration to our theme and set it to disabled by setting the enabled parameter to false. This is just an example. In your own projects, feel free to keep the credit link as a courtesy to the Highcharts developers. If we look at our dashboard again, we see that the link has gone from both our charts, proving that the theme really works. To sum things up, you can do pretty much everything in a theme that you can do in a standalone chart and apply it to all charts on the page by calling the setOptions function provided by Highcharts. In the next video, we're going to create another chart, this time one that is a little more exotic, namely a heat map chart. This video is all about creating a so-called heat map chart. We're going to design a heat map chart to highlight the web pages and the times these pages have had the most hits. After that, we're going to get a feel for what we can do to tweak the tooltips a little, and finally integrate the chart into our dashboard. Let's start off with a heat map example on highcharts.com/demo and go to JSFiddle from here. As you can see, the heat map chart is basically a two-dimensional matrix with values in each field, and each field is colored according to its value. On the y-axis, we want to display the names of the 5 most active web pages, and on the x-axis, we want to display the day of the month. The fields of the matrix will be filled with the number of page hits on a page on a certain day. This way, as a webmaster, we can see very quickly when and where the most action is on our website. First off, note that heat map charts require you to include the special JavaScript file heatmap.js, which is available at code.highcharts.com as all other Highcharts JavaScript files. Let's go through the configuration and change it on the way. We see that the type of the chart is configured to heat map. Remember that for charts other than line charts, the type has to be configured this way. The margins are for positioning the chart. We will leave them like that for now. We delete the title configuration since the title is included in the theme we created in the previous video. Next, the x-axis. We learned to use a datetime axis for dates, so we will do just that and configure a datetime axis. The x-axis label looks a little strange for now, but we will fix that later. On the y-axis, we want to display some of the pages of our website. We will just drop in some random page names for now. The next interesting configuration is the so-called color axis. Here we can configure the color range to be displayed in the heat map. The current configuration goes from white to the first default color of Highcharts, which is this blue and which is fine for us now. The legend and tooltip configurations will stay like this for now. Now we want to add the series data to fill the heat map with the page hits for the last 30 days. For this, we first build an array with exactly 30 elements, and each element containing the timestamp of one of those 30 days. This array will save us some code later. Let's look at the series configuration now. We don't need a name, but we need the call size configuration. This defines the width of a column in the heat map, which should be exactly 1 day. And this is the number of milliseconds in 1 day. Now the data. We'll just paste in some random data for the sake of example. You can find this data in the source code for the next video if you want to copy it. For a heat map, each data point consists of 3 values. The first value is the X value. In our case, this is the date. Here, the array we created earlier saves us some code. The second value is the Y value. Since we have 5 elements on our y-axis, the values go from 0 up to 4. The third value is the value to be displayed in the heat map. In our case, this is the number of page hits on a certain day on a certain page. You will notice that now the heat map fields are much too small to display the labels. So we remove the so-called data labels configuration. Now, if we hover over one of the fields, we see that the tooltip does not really match the content anymore. Let's go back to the tooltip configuration to fix that. Let's say we want the tooltip to display a text like, "This page was hit so many times on this day." We can do this by simply changing the return value of the formatter function to something like this. The formatter has access to a handful of variables like this.point and this.series, which we can use to get the data we want to display in the tooltip. If we hit run now and hover over one of the fields, we see that the tooltip is updated. So that's the heat map chart. Once it is copied into our dashboard, it should look something like this. To wrap things up, in this video we learned how to create a heat map chart. For a heat map to work, we need to include the special file heatmap.js, so don't forget this file when integrating the chart into the dashboard. Other advanced chart types need other JavaScript files like, for example, highcharts-more.js. Just look at an example to see which files you need. As for tooltips, we can do whatever HTML provides and access some Highcharts variables, which are documented in the Highcharts API. Upcoming in the next video, we're going to build a chart containing a geographical map. In the previous video, we created a heat map chart. In this video, we're going to create a similar chart, but backed with real geographical data using HiMaps, a spin-off of Highcharts. First, we're going to have a look at the basics needed to create such a geographical map chart, such as selecting a map to display. Next, we will look at the data structure needed to fill such a chart with numbers, and then go through the configuration options of a map chart. Let's have a look at how to create a map chart. This is the Getting Started section of the HiMaps documentation. Of course, the first step is to include the right JavaScript files for HiMaps to work. Next, we have to load the map we want to display. Highcharts provides a map collection you can choose from, or you can create your own. We will go with the default world map, which looks something like this. Let's look at the code for such a chart. As before, we will simply start off with an example chart provided by the Highcharts developers, this time in the demo section of HiMaps instead of Highcharts. We start with a chart labeled Fix Tooltip with HTML and go to JSFiddle from here. In the first line, we already see a difference to all the charts we have seen before. Here, the chart data is loaded from a URL instead of from a simple JavaScript variable. When we look into the data at this URL, we see that it simply contains 3 data values for each country of the world. First, the country code, second, the full name of the country, and third, the value to be displayed in the chart for this country. Okay, back to the example chart. We leave the data loading in place like this for now so that the example still works. These 3 lines of code are for the little flags in the tooltip to work. We will delete them for now because we won't need the flags later on. We also delete the title configuration since our theme will take care of that. The legend gets a meaningful title like page hits. The style of the legend stays as it is. This simply means that the text color of the legend will be the text color defined in the theme, or black if none is defined. The map navigation configuration allows to configure zooming of the map. we'll leave it as it is. The tooltip is a little different from the tooltips we've seen so far, since it is always displayed in the lower left corner of the chart. This is thanks to this positioner function here. We'll leave the tooltip configuration in place, but remove the flag display since we do not have the CSS classes used here in our dashboard. Also, we remove the square kilometers suffix here, since we won't measure the area of the country anymore, but the number of page hits from that country. The color axis configuration is currently set to logarithmic. We'll delete the type configuration so it becomes a proportional axis. Now to the most important part, the series configuration with the data. You can see that the data loaded from the URL above is simply passed into the data configuration of the series here. Also, the map we want to display is selected here. The JavaScript file for this map has to be included in the HTML like this. The next important thing is the join by configuration. This defines how your data is mapped to the countries in the map data file. The first key is the key to the country in the map data file, which is world.js in our case. And the second key is the key of this country in our data file, which is this format in our case. Okay, let's quickly change the name of the series to something more fitting like page hits, and we're done with this chart for now. For an example integrated into the dashboard, have a look at the code of the next section, which looks something like this once it is integrated in the dashboard. In this video, we learned how to create a map chart. You can create your own map or select an existing one. You have to create your own data to display in the map, which is joined to the country by a certain key that you can define. The rest is pretty much the same as with most other chart types. In the next video, we will have a look at Highstock, which is another spin-off of Highcharts. Stock charts are charts displaying the history of stock values over time for a certain company that participates in the stock market. These stock charts have some special features that we're going to have a look at in this video. After that, we will create a stock chart and put it on a special stocks dashboard in our dashboard application. Finally, we will have a look at the complete dashboard application we have created so far. Let's start off with the chart on the Highcharts demo page once again. This is a simple stock chart. As you can see, we have some new elements here that other charts do not have. On the top, there is a zooming functionality called the range selector. Here, you can select which time range to display, either via predefined buttons on the left or via data input fields on the right. On the bottom, there is a mini chart that is called the navigator. Here, you can select the start and end date by dragging these handles here. Finally, all the way on the bottom, there is a scroll bar which is directly connected to the navigator. All these new elements can be configured. In the range selector, you can configure your own buttons. In the navigator, you can configure the X and Y axis like in a normal chart. All elements, including the scroll bar at the bottom, can be enabled or disabled, and their look and feel can be configured. Okay, let's have a look at the configuration of the chart. Since the chart looks pretty good already, we won't change very much of the configuration for our dashboard, but we will remove the title configuration since our theme will take care of that, and we will disable the navigator at the bottom. The data for this chart is loaded via jQuery's getJSON function, which we've seen earlier already with the map chart. We'll leave the data loading in place here and go back to it in a later video. The range selector is configured so that the button with index 1 is activated by default. This is the 3 months button here in our case. We also add another configuration to the range selector, which takes care of hiding the date input fields if the chart is less than 480 pixels wide. This helps when the chart does not have enough space to show these input fields. The rest of the configuration is and stays pretty much default. Now, let's take this chart into our dashboard application. As you can see, I have created a new HTML file, stocks.html, and a corresponding JavaScript file, stockcharts.js. The HTML file defines a new dashboard with 2 widgets for stock charts, one for Google and one for Facebook. It includes the file highstock.js as well as our new JavaScript file stockcharts.js. I pasted the chart configuration in the stockcharts.js file already and added a small theme at the top which sets all charts to a height of 200 pixels. The end result looks like this. We now have 2 dashboards full of charts to work with to show some of the advanced features of Highcharts in the upcoming videos. We've seen that stock charts have some unique features with the range selector, the navigator, and the scroll bar. Other than that, they are just normal charts. You can find the code for the dashboard application we created so far in the folder section-2-final of the code package. Our dashboard application is ready now for some more action in the upcoming videos. We will look at how charts can interact with other UI elements in the next section. Welcome to section 3 of the Highcharts video course. In this section, we will find out how to make our charts a little more interactive, enhancing the user experience of our website. In this video, we're going to add drill down functionality to our line chart. For this, we're first going to have another look at our line chart and define how the drill down should behave. Then we're going to add new data to the chart and configure the drill down functionality to show that newly added data when a point on the chart is clicked. This is the current state of our dashboard. We want to add drill down functionality to our line chart here. Drill down means that the chart is supposed to show more detailed data when a point on the chart is clicked. Each point currently represents the number of page hits on one day. Now, if we click on a point on the chart, we want the chart to show the page hits for each hour during that day instead. Let's find out how we can do this by looking at the code. As you can see, I restructured the files a little for this exercise. I created a subfolder for each dashboard, one named Stocks and one named Web Stats. Also, in the Web Stats dashboard, I pulled the line chart configuration into its own file called linechart.js and included this file in the HTML file. This JavaScript file is where we want to add the drill down configuration. First, we need to define what data should be displayed when clicking on each point in our chart. The chart has 30 points, one for each of the last 30 days, so we need to define 30 additional data series, each containing 24 data points, one for each hour of the day. For this, we create an array called drill down series, which will hold our 30 drill down series. We loop from 29 down to 0 for each of the last 29 days plus today. For each day, we calculate the midnight date of that day and store that in the variable start date. Next, we create an array of 24 random numbers, one for each hour of the day. In real chart, this data would not be generated randomly, of course. Finally, we create a series object with the calculated start date, a point interval of 1 hour, and the randomly created data. Also, the series needs an ID so we can use it later to configure the drill down. This series object is pushed onto the drill down series array, making it an array of 30 series objects with 24 random data points each. We can add this array to the chart configuration now using the drill down configuration option like this. We're not done yet though, because the chart doesn't know which of the series in the array to show when one of the data points is clicked. So we have to configure some kind of mapping between the data points of the original series and our drill down series. To do that, we add the drill down configuration to each of the data points of the original series like this. In the drill down configuration of each point, we simply define the ID of the series that is to be displayed when the point is clicked. In the code above, we simply use the IDs 0 through 29, so we just use the same IDs here. The actual value of the point is moved into the Y configuration here. Finally, we have to include one more JavaScript file into our HTML file. The name of that JavaScript file is drilldown.js, which is provided by Highcharts. So let's save the code and have a look at the result. The chart looks just like before, which is expected. Once you click on a point, though, the chart changes to show 24 random data points going from midnight to 11 p.m. on the day you clicked. Once you drill down, Highcharts automatically shows a button you can use to go back to the main chart. It's labeled with the name of the main series by default. If you want to display a different label on this button, you can configure the text in the language configuration of Highcharts, which you can look up in the API documentation. So that's our drill down chart. Let's review this video. To create a drill down chart, you have to create a data series for each of the points that should have a drill down functionality and connect the points to the series by ID. Also, we learned that data points can be more than just numbers, but instead they can contain a whole JSON structure with several attributes. We only use the attributes called drill down and Y here. Have a look at the API documentation to see what else you can configure for each point. In the next video, we're going to teach our charts to interact with form input components. In this video, we're going to add more interaction to our web stats dashboard. We do this by adding a date range input field and some JavaScript to read the dates from this input field. We will then use those dates to refresh all charts on the dashboard at once. If we open the web stats dashboard in section 3.2 of the code package in a browser, it looks like this. Note the new input field and button at the top. If you click on the input field, two calendars pop up, one to choose a start date and one to choose an end date. The refresh button doesn't do anything yet though. Let's think about what should happen when we click that button. What we want is that all charts are updated with the new data according to the new start and end dates. In a real dashboard, the charts should then show only statistics about page hits that happened in the selected date range. We will add random data instead though, since we do not have a data source to load real data from. Besides showing new data, the x-axis of our line chart and our heat map chart need to refresh to be adjusted to the new start and end date when clicking on the refresh button. And of course, the number of data points in those two charts needs to be corrected to match the number of days between the new start and end date. Let's review the code changes that were made to add the new date range field. First of all, we need a new input field and a button, which are simply added together with some boilerplate code that is needed to fit them into the theme. Both the input field and the button get an ID, so we can address them later on. Next, for the date range input field to work, we have to include certain CSS and JavaScript files that come with the theme we selected for our dashboard. One such file is daterangepicker.css at the top, and another is daterangepicker.js at the bottom. We also include a JavaScript file of our own, refreshcharts.js. The code in this file is responsible for refreshing the charts after the button is clicked. Looking into this JavaScript file, we see some jQuery magic that turns our simple text field into a date range picker. Also, there is some code that is executed when the refresh button is clicked. This code first gets the selected dates from the date range picker and parses them into date objects. These are passed into 4 refresh functions, one for each of our charts in our dashboard. Scrolling down, we see that these functions are empty yet, so let's take the refresh line chart function and fill it with some code. First, we get the chart from Highcharts, and from it we get the object representing the series. Note that I added an ID attribute with the value main series to the series configuration of that chart earlier. Next, we create a data array with new random data. This array must have one data point for each day between the start and end date, both inclusive. We use the helper function getDaysBetween here to calculate the number of days. Each data point will have a random number between 1 and 50. Finally, we update the series of the chart using the update function provided by Highcharts. As a parameter, we pass in a JSON object containing the configurations we want to change. In our case, we want to change the starting point of the date series to the new start date. We add another day here to avoid an off by 1 error. Also, we want to change the data of the series to the new data we created. And that's it. If we choose 2 dates now and click the refresh button, we see that the chart refreshes to the new number of days. When we fill out the code for the other 3 refresh functions, the result will look like this. All 4 charts will be updated once the refresh button is hit. To wrap things up, you can use any DOM manipulation framework you like to make your UI elements more interactive, like we did with our date range field and jQuery. Then create your own JavaScript code that creates JSON objects and calls the Highcharts API functions to interact with your chart objects. Note that there are more functions than the update function we used in the example. Have a look at the API documentation if you want to know which functions are available. So much for using form input to manipulate our charts. In the next video, we're going to have a look at the data exporting functionality that Highcharts provides. After the previous video, we're now able to configure our charts on the fly by entering a new start and end date. Maybe by entering specific dates, we found a chart that we want to show to a colleague. That's what the exporting feature is for. In this video, we're going to add a button to all our charts that allows us to export the chart in one of the several available formats. Since the chart data is sent to a server to be transformed into the requested format, we will then discuss some privacy issues. First, let's go and add that export button to each of our charts. To support exporting, we need to include a special JavaScript file provided by Highcharts. The file is called exporting.js. Simply include the file into your HTML file like this. Now we need to configure each chart to show the export button. Remember that we have a theme that allows us to make global configurations that are applied to all charts on the page at once. So the theme is the thing we're going to modify here. The theme is configured in the JavaScript file charts.js of our dashboard. The exporting feature is just another configuration. Simply add the exporting configuration to the theme with the enabled flag set to true like this. This configuration will now apply to all charts, and the charts will show an exporting button. The exporting button is this little button on the top right of each of the charts. If we click on it, it will show a menu providing some exporting options. You can choose to either get a printing view of the chart for a quick printout, or to export the chart into PNG, JPEG, PDF, or SVG format. When exporting, the file is downloaded and you can do with it whatever you want, like mailing it to your colleague. There are some more options to the exporting configuration. If you have a look at the API, you will see that you can configure the look and feel of the button, configure a default file name for the downloaded file, and more importantly, you can configure a URL. This is the URL of the server to which the data of your chart is sent to be converted to, say, the PNG file we just downloaded. By default, the data is sent to a central exporting server provided by Highcharts, so you should be careful what data you send there. If you have a problem with sending your data to some unknown server, which should be the case for most commercial web applications, you can set up such a server yourself. Setting up that server takes a little experience in Java applications, but the description provided by Highcharts should be easy enough to follow. If it's a use case for you, you can even set up the server to render the charts and save them on the server to do some automated processing like sending them in emails. So that was the exporting feature. Keep in mind that you have to include a special JavaScript file to enable the feature. The rest is simple configuration within your charts or your theme. Also keep in mind that by default, your chart data is sent to a server in the internet. So to keep your data private, set up your own server and secure it with SSL. That was section 3 of the Highcharts video course. In the next and final section, we're going to load the data used for our charts from several different data sources instead of simply configuring them manually in our JavaScript files. Welcome to the last section of the Rapid Highcharts video course. In the last 3 videos, we're going to investigate the possibilities for loading chart data from different sources. In this video, we will cover data that comes from our own server in CSV format. First, we're going to have a look at our CSV files that contain historic stock data, and then we will parse that data and finally add it to our stock charts in the dashboard. Our stocks dashboard has 2 widgets, one displaying the stock values of Google and the other of Facebook. The charts are currently empty since we still have a little coding to do to make it work. Have a look at the file stockcharts.js. There are 2 charts defined in this file. Note that the charts are now defined within a callback function of jQuery's $.get function. The get function calls the URL passed in as a parameter and passes the contents of that URL into another callback function, in our case into the parameter CSV file. I have prepared 2 CSV files that contain the data that should be loaded into our charts. Let's see what that data looks like. Just open one of the files in a code editor. As you can see, it is just a simple CSV file containing a date column followed by 5 data columns. This is the data that is passed into our callback function as parameter named CSV file. Now we just need to parse this data and put it into our chart. I already prepared an empty helper function called parse CSV data that will help us parsing the data. The function takes the CSV data as an input and returns the data in a format that Highcharts understands. This data is then simply added to the chart as usual. Let's go into the function parse CSV data and have a look at how we can parse that data. First, we simply create an empty array that will store all our data. Next, we split the CSV data into several lines using JavaScript's split function. And now the interesting part. We loop through all the lines. We skip the first line since it contains the column headers. We then cut the line into separate fields. We expect exactly 6 fields per line. If there are more or less lines, the line is ignored. If the line was valid, we read the timestamp from the first and the value that belongs to that timestamp from the 5th field. Finally, we push the timestamp and the value belonging to it into the data array in the format that Highcharts expects. If all went well, we have a full data array now. We need to reverse that data array though, since Highcharts always expects the data to be sorted chronologically from older to newer data points. Otherwise, we'll get an error from Highcharts. Let's save this and have a look at the dashboard. As expected, one chart now displays the stock history of Google and the other of Facebook. And that's the result. Let's review what we've done. We use jQuery to load CSV data from an external source and to parse that data. Then we used simple JavaScript to transform the data into a JavaScript array that Highcharts understands. This array we used as an input for our charts. So in this video, we learned how to load static data from an external source. In the next video, we will learn how to load real-time data and automatically update our charts with fresh data every couple seconds. In the previous video, we loaded historic stock data in CSV format from an online source. In this video, we're going a step further and load real-time stock data from an online source every couple seconds and update our chart with that real-time data. For that, we first need to find such a data source and then do a little programming to load the data from that source and some more programming to update our chart with that data every couple seconds. So we're looking for some free online service that provides us with the current price of a certain stock. There is a service provided by Yahoo for such cases. Yahoo's Finance API provides a query language that we can use to get specific stock data. In our case, we just want the current stock price for Google and Facebook. We simply have to call a specific URL with a query as one of the parameters. The result is a JSON data structure that we can easily work with in JavaScript. Before integrating the Yahoo Finance API into our dashboard, let's take a look at the code that was prepared for this video. The code is contained in the file stockcharts.js. As before, we have two charts defined in that file, one for Google and one for Facebook. However, we have replaced the stock charts with simple line charts for the demonstration in this video. The reason for this is that the stock charts currently have a bug that makes it impossible to update charts with real-time data while the navigator is disabled, which is the case in our stock charts. We also have added a call to the JavaScript function setInterval. The callback function we pass into that function is executed every 2 seconds. This function calls the function getRealTimeData to load the real-time data for Google and Facebook and update the charts with that data. Let's start with filling out the getRealTimeData function. Once again, we rely on jQuery to do the major work for us. We use jQuery's AJAX functionality to call the Yahoo Finance API URL we saw earlier. We're using JSONP as the method to allow our browser to do AJAX calls cross-domain. In the success callback function, we take the value bit_realtime from the JSON result, add the current timestamp to it, and pass both into the callback function that is passed in as a parameter. This callback function is defined when we call the function getRealTimeData. Here, now we can work with the data. Having the data, we now need to add it to our chart. Highcharts provides the addPoint function to add a data point to a series. For this, we first need to get the chart from Highcharts, and from that chart, we need to get the series that we want to add the data point to. The addPoint function takes the point data as the first parameter. The second parameter determines if the chart should be refreshed after adding the point. We want the new point to be immediately visible, so we set it to true. The third parameter defines whether the leftmost point of the chart should be removed when adding the new point at the right. This is handy for real-time charts, since the chart might get very cluttered after a lot of points have been added. We want to add 10 points before starting to shift, so we only set this value to true once we have added those 10 points. We can now add similar code to the other chart and have a look at the result. The resulting dashboard now looks like this. The charts are empty at the start, but every 2 seconds a new data point with the current stock price is added to each chart. Once the charts each have 10 points, the first point will be removed when a new point is added. Note that if you open the dashboard at night when the stock market sleeps, you will always see the same value. Only if the stock market is currently active will the value change between two data points. We created two rather basic charts and added a little jQuery magic to load data from an online source via AJAX and JSON-P. From this data, we extracted the current stock price and added it via the addPoint function provided by Highcharts. To have a nice-looking chart, we used the shift parameter to have the first point removed once a new one is added. In the next and last video of this course, we're going to see how to load data from an HTML table. All the charts we have created so far put those people into a disadvantage that cannot process visual data. So, in this last video of this video course, we will discuss some accessibility issues and then find a way to overcome them by putting the data we want to display into an accessible HTML table and create a chart from that data. Let's first discuss why charts are not accessible by default. Charts like these here display data visually. For most people, this visual data representation is considered far better readable than simple data tables. However, there are people who cannot make use of that visual representation of the data, for example, because they have bad eyesight. So, if you want to include those people into your audience, you have to provide an alternative representation of your data. This alternative way is also called accessible, since more people can then access it. There are some organizations that create guidelines for accessible web content, like the Web Accessibility Initiative and WebAIM. If you're not sure how to create accessible web content, consider searching their websites. Let's try to make an accessible chart. I have prepared a separate dashboard that contains one widget containing the web stats data in a table. Below that is another widget that should later contain a chart displaying the same data parsed from that table. Now, you might say that if a person has bad eyesight, he cannot read the data table any better than the visual chart. That's not entirely true, because he may zoom the text large enough for him to be able to read it, or if he has no eyesight at all, he may use a screen reader that reads the text on screen to him so he can listen to it. So, a table is one way to display the data in a more accessible manner. This table here contains the page hits on 5 different pages over the last week, going from Monday through Sunday. The goal for us is to display the data in an accessible way, like this table, and additionally in a visually appealing way in a chart in this widget down below. So here's the data in a table. How can we create a chart that displays that data? It should be a line chart with 5 series, one for each of the 5 pages in the table. Let's look at the code. In the HTML page, we added a rather simple data table. Note that this table has some simple additions to make it more accessible. Here, we added the scope attribute to all header fields. This attribute tells tools like screen readers if the header belongs to a row or a column, so it can read it to the user in the correct sequence. For more accessibility features of HTML tables, have a look at the websites I mentioned earlier. Now to the chart. This is a simple spline chart without data. A spline chart is just a line chart that has smooth curves. To read the data from the table, we have to add the data configuration. Here, we simply define the ID of the table whose data we want to display. And that's it. We can save it and refresh the page in the browser, and the result looks like this. We now have a chart with 5 series displaying the same data as is listed in the table above. People can now choose which representation of the data they like better. Note that for the chart to be displayed correctly, you must create the table in such a way that a series is always represented by a column in the table. If you want more flexibility in your table structure, you can still fall back to using jQuery or another JavaScript framework to parse the table data by hand according to your requirements and pass it into the chart. This excursion to accessibility issues concludes the Highcharts video course. We created an HTML table containing chart data and a chart that displays the same data visually. If the table disturbs you, you may even make it invisible so that only screen readers find it and can read it to their users. I hope this video course highlighted some of the features of Highcharts in a way that helped you getting started. Thanks for your attention and have fun creating your own charts. Bye bye.